Hello, everybody. So today, we are, if I go to the stream, maybe. Well, today we're starting with this. So it's bacteria and antibiotics, PowerPoint. Um, kind of going through like bacteria, how it grows, and how antibiotics end up killing that bacteria. So to start off with the first slide, what is bacteria? So it's a single-celled organism. Usually, you can see with a microscope. What you see on these plates here, these are bacteria colonies. So there's thousands, if not millions, of bacteria that live in each of these little circles. And so you would need a microscope to see each one individually. Otherwise, um, it's a colony. Um, they're found almost everywhere. They reproduce asexually, which means that they reproduce through cellular division. Um, so, like uh, in sexual reproduction, it's half of the chromosomes or half of the DNA from the mom, half of the DNA from the dad, and comes together to make a full set. In asexual reproduction, it's always like humans. We have, I think it's 24. Maybe I'm wrong on that, but let's say it's 24 chromosomes or 24 um, things. Well, I guess it wouldn't be chromosomes, but anyway, so that DNA is going to be 1 to 1. So basically, it's one cell, and it just basically pulls apart into two. They're identical, and that's asexual reproduction. Oops. Uh-oh. Um, it can be helpful. So if you've ever had yogurt, that helps with your digestion. It can also cause people to become sick, as you know, with like I think pneumonia might be a bacterial infection. um, Staph, I think, is also another one, but yeah, so they can cause people to become very sick. The next, what is the difference between bacteria and viruses? So viruses are an RNA, um, uh, I guess, organism, while bacteria is a DNA organism. And so the the RNA, like you can't use um, antibiotics to kill a virus because it doesn't necessarily like affect it the same way. So RNA kind of like it like runs your DNA through an RNA splitter, and it like basically affects your DNA with a virus. But a bacteria just kind of like lives inside and attacks your body that way, or affects your body that way. While a virus kind of gets into the cell and affects the DNA that's in your cells. Um, why do we care about this difference? So obviously, it has like the bacterial infections are much easier to treat, since the viral infections you can't use antibiotics on them, and it's just hard to take care of them. As we can tell with COVID, which is a virus, so we need some sort of vaccine to rid us of that. Uh, in 1920, or yeah, 1928, Alexander Fleming discovered the first antibiotic. It was penicillin. So you can see here, like this penicillin uh, is stopping or inhibiting the growth of this bacteria, which has been swabbed kind of in this zigzag pattern. And this is actually staph, so staph infection. And you can see that like creates this ring around the penicillin. And so whenever we give penicillin out, um, it can stop the growth of staph infection. And here's another example of the difference between uh, bacteria infections versus viral infections. So you have tuberculosis, urinary tract infections, sinusitis, chest infections, tetanus, botulism. Uh, these usually are localized to a certain area, and you can use antibiotics on them. On the other side, you have like the common cold, sore throat, um, bronchitis. You also have COVID as well, and it affects the whole body because it ends up affecting the DNA of you, kind of splices that in. And then it cannot be solved with antibiotics, so there has to be some other means for it. It can mutate. So obviously, if you just like any organism, like you can end up having mutations kind of go haywire, or excuse me, not haywire. Sorry, you can just have things mutate. Like the genes might always not be passed down a generation. And so here's this video that you can watch, and I'll post this on Google Classroom so that you can watch this as well on your own. So it's not playing through a video because that'd be kind of odd. Uh, and then what we can do, so if you're prescribed antibiotics, take them. They're beneficial. Obviously, they're going to stop the growth of that bacterial infection that's inside of you, and that's always a good thing. Try taking some vitamins when you start feeling sick. So you might have heard of like vitamin C, other stuff like that. With COVID, I don't know how true it is, but I heard vitamin D supplements can decrease the severity of some symptoms. I need to double check that, but when I had COVID, that's what I was taking as well, um, and it kept it pretty mild. Uh, Keep wounds clean, obviously, to avoid infection. Like if you fall or something, clean it up. Um, yeah, and it's okay to use antibiotics. Just don't become over dependent on them because of things if you use a bunch of antibiotics, then the bacteria will mutate, and it will obviously, as we have seen from natural selection, the strongest survive, and so the ones that are resistant to that antibiotic will be the ones that end up surviving and passing those traits on and on and on. And so it's okay to use antibiotics, but don't use them an over reliance on them. And then lastly, we have some new developments. So antibiotics are always being tested and developed. Um, and there's also been this discussion of bacteriophage. So the use of viruses to purposely attack and kill harmful bacteria. So it's kind of like turning the tables almost on its head. But yeah, so these are some things that we're going to be talking about during the assessment, I believe, on Thursday. So if you have any questions about that, let me know. Um, and we'll go from that. So that's the first thing. The second thing was we are going to be looking at the seasons model assessment. Excuse me. So right here you have your season model assessment. If you click on it and it loads in, I did leave a private comment on there, so that's what you'll see first probably. But that is not the only feedback that I have given. You're going to have to actually go into the document itself, which I have right here. And I left comments. Obviously, this is just a template, but I left comments on your answers. So over on the side, if they, let's say, question number 8, um, I wanted you to elaborate more a little bit on something, I would leave a comment right here. And so just type your answer into question 8, blah, 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 blah. You type your answer here, um, and then you can resolve that comment over on the side. And I'll go back through and regrade once you uh, or excuse me. So once you've gone all the way through, you've made those updates, those revisions based on my questions. Make sure that you hit that turn in button. If you don't hit the turn in button, I don't know if you made any revisions, and I don't grade it. So make sure that you hit that turn in button in the top right. Um, Once you are done with that, again, this is the only grade that's in the grade book right now. We will have the natural selection quiz, I guess, test coming up on Thursday. That will be the second grade that's going into the grade book. This is the first. So if you're not happy with your grade, this is where it's coming from. So make those revisions. I'd be happy to help clarify any feedback that you have or any questions that you have on the feedback itself. Otherwise, just power through, turn it in, and I'll get back to it. So I'd much rather grade a something that you've taken your time to work through, rather than something that you've just like thrown together and resubmitted. If it's just something that's been thrown together, it's probably not going to change your grade too much. So make sure you take your time, be diligent and thorough on your answers. And then lastly, we have the natural selection review worksheet. So we have some vocabulary terms right here. I want you to write your own definition of these ones. And then, of course, how these terms relate to natural selection. For natural selection itself, it can't really relate to itself. And then lastly, use an example of this term. So not just from the bunny simulation, but like from other activities that we've done in class. Um, use use those so that you can kind of like refresh your mind. Where does mutation pop up, or where did variation? How about artificial selection? Where do we talk about those things? So if you need to review those, you can go back and look at those activities. The next activity or the next question is having you identify three traits, three different traits in this population of snails that are down below. So you have three, uh, I guess, boxes here, and also you need to make sure that you state how these traits may vary among individual organisms. So not just like within the species, but within the actual organism itself. Next, we have identifying three different traits that this sloth has. So you're going to explain not just what these three traits are, but how this helps the sloth be successful in its environment. Okay, so make sure that you're also adding that into these three boxes. And then we have an image of some giraffes. So we have this one on the left side, and then we have some on the right side. And so you're going to use this image here to answer these questions down below. These one, two, three, six questions down below right here. And that's the end of it. So if you have any questions on the review worksheet, of course, let me know before Thursday so I can help you out. Right now, it's looking like our assessment will be Thursday because I want to give you more time to finish the season model revisions in class. I also want to give you time to finish this natural selection review and ask any questions that you have. So, uh, looks like Thursday will probably be our day. And then from there, we'll start moving on to an artificial selection project. So we're kind of doing a project and a quiz or a test, I guess, for this unit. If you have questions, let me know, and I'd be happy to help you out. Have a great day.